APCalculus, Notes 9.1, we are doing an example of solving a triangle that's oblique. So first thing we want to do is draw a random triangle ABC, label the angles, A, B, and C, label the sides opposite those angles, same letters but lowercase. We're told that side A is 12, side C is 7, angle B is 65. Or to solve this, we're going to have to use law of sines or cosines. We cannot use right-angled trig because we don't have a right triangle. In order to use law of sines, we have to have an angle and the side opposite that angle. We don't have that, and there's no other angles to find to help us to be able to do that. So we're going to start out with law of cosines. Which law of cosines equation do I use? I'm going to use the one that uses angle B, and that one starts out with angle B, or with side B. B squared is A squared plus C squared minus 2AC times cosine of the measure of angle B. Don't know what B is. A is 12, C is 7, measure of angle B is 65. Simplify this as best we can, knowing we have 1, 2, 3 terms, and only 2 of those are like terms. So on the left, B squared is 144 plus 49. 2 times 12 times 7 is 168. Cosine of 65 we do not put into our calculator because we don't want to round until the last step. Combining 144 and 49, we get 193. Just going to make B plus or minus this hot mess right here. Excuse me. Even though we're saying technically mathematically B is plus or minus, this is the length of a triangle. In this context, it's going to be positive. Put that in your calculator, you're going to get 11.045. That's an approximation. So to solve the triangle, that means find all the missing measurements. Now to finish this, we got 2 choices. If we can avoid using the rounded number, we want to avoid using it. So we could use law of sines, because we have an angle and side opposite of it, but we'd have to use the rounded number. We could use law of cosines and use all 3 of these sides to try to find a missing angle. We'd have to use a rounded number. We have no choice but to use a rounded number. If one person used law of sines to finish this problem and someone else uses law of cosines, your answers are going to be slightly different because we're using rounded numbers. I'm going to choose law of sines to finish it because I think it's less work. Sine of angle B, which is 65 degrees, over its opposite side, 11.045, should equal, say I want to find the measure of angle C. It's going to equal sine of the measure of angle C over its opposite side of 7. To get measure of angle C by itself, it's pretty easy. I'm just going to multiply both sides by 7. It's going to give me 7 sine of 65 degrees over 11.045 equals sine of the measure of angle C. To get the measure of angle C by itself, I'm going to use sine inverse on both sides of the equation. Anytime you apply sine inverse, you have to do it to the left side of each side of the equation. Over on the right side here, the sine inverse and sine cancel, and we get the measure of angle C. Put this in your calculator, you're going to get about 35.057, knowing that it's slightly wrong because we used a rounded answer. Once we know what that is, we can find the measure of angle, the other angle A. All the angles in a triangle add up to 180. So we got a 65 degrees and a 37.057 degrees plus the measure of angle A equals 180. If you add those together and subtract them from 180, we're going to find that the measure of angle A is about 79.943 degrees. We finished the problem because we found all the missing parts. We were given 3, and we found 3 more. Finally, this concludes the section 9.1, which was reviewing special right triangles, right angle trig, law of sines and cosines, and introducing how to find the area of an oblique triangle.